In this video, we're going to take a look at molecular compounds, both how to name molecular compounds and how to get the formulas from their name. So we'll look at binary molecular compounds. Again, binary meaning two, so made up of only two different elements, not just two different atoms. It could be 5 different atoms, but only made up of two different types of atoms. So those two atoms both need to be of non-metals, because now we're talking molecular, so we're going to be making covalent bonds, sharing electrons, not transfer electrons. So we can't use ions like we did before to then name the ion when we name the compound, or for when we put the compound together from its name. So molecules are very different than ionic compounds, because ionic compounds, with the exception of transition metals, they get together maybe one, if at most two different ways, again, the transition metals. So we can't use this same type of naming system. So we need to use prefixes, as you probably know from these two compounds here, CO and CO2, carbon monoxide and carbon dioxide. Again, this is just one example of two different compounds coming from a combination of the two same elements, but there are many other ones that make even more than just two. So we're going to use prefixes, like we got from the carbon monoxide and carbon dioxide, to let us know how many different atoms there are of each element within that compound. The metallic one still goes first, so the one that's closer to the left, closer to the staircase, will always go first in both the name and in the formula. So again, like ionic compounds, you can just keep the order exactly the same as they were in whichever direction you are going. And then the second element, like we did see with ionic compounds, is still going to end IDE. So the first element, if it has just one atom, we don't use a prefix though for that, because it gets a little bit redundant. And again, so we notice that with the carbon monoxide, it's not monocarbon monoxide. And also, as we notice that name, if you have like a double up of vowels with O's and A's, you end up dropping one of those vowels. You don't have to repeat the double vowel sound, except with I's, like you'd have triiodide, then that will double up. So those prefixes, again, we just went through a few, but here they are all the way up through 10. 1 again being mono, 2 is di, 3 is tri, 4 is tetra, 5 is penta, 6 hexa, 7, you gotta be careful, 7 is hepta, not septa like one would probably think, but hepta. 8 is octa, 9 is nona, and 10 is deca. So we see here, again, carbon tetrabromide is what this would be, because again, you have one carbon, you don't need a mono in front, 4 bromines, so tetra, and then again, the second one ends IDE, so tetrabromide. And then we see here, phosphorus and sulfur, I got 4 phosphoruses, so tetraphosphorus, and then 9 sulfurs. Again, it ends IDE, and the prefix for 9 is nona, so nonasulfide. Tetraphosphorus nonasulfide. So to get the formulas, again, for ionic compounds, simply just use those prefixes to tell you what that subscript is in its formula, then put them in the correct order, again with the appropriate subscript. So dinitrogen tetraoxide, so now we're going to, again, keep the symbols in the same order as the names in the name of the compound. So nitrogen's first, so it's first in its formula. So dinitrogen, that tells us subscript of 2. Tetraoxide, and tetra tells us subscript of 4, so N2O4. And also we see here phosphorus pentabromide, again, no mono in front, but so that does indicate that there is still one phosphorus. Pentabromide, penta telling us 5, so 5 bromines.